So let's take a look at calculating cell potential for a galvanic or a voltaic cell, and it works for electrolytic cells as well. So just to start with, you'll need to know the formula. So the formula that we see here, that the E of the cell, so the cell potential in volts, will equal the cell potential at the cathode minus the cell potential at the anode. So for galvanic cells, which are also known as voltaic cells, your cell potential is always over the value of 0, and your reaction will be spontaneous. For electrolytic cells, your cell potential will be less than 0, and your reaction will be non-spontaneous. So let's take a look at our first example here. So our example, you want to start off, we know we have a voltaic cell. Well, we don't actually know that yet, but we will figure that out because it's going to be spontaneous. List your OAs and your RAs. So zinc solid is an Ra, 2 positive is an OA, copper 2 positive is an OA, and copper solid is an Ra. Your strongest reducing agent is your zinc, and your reducing agents undergo oxidation, and this happens at your anode. So we'll grab that cell potential from your data booklet, and it's negative 0.76 volts. Then for your copper half reaction, we have that your copper 2 positive will be your strongest oxidizing agent. Oxidizing agents undergo reduction, and that always happens at the cathode. So we'll grab that half reaction's value from your data booklet, and it's positive 0.34. So if you want to calculate the total voltage produced by this cell, and we know it's going to be a voltaic cell because your OA is higher on the table than your Ra, so that means you have a spontaneous reaction, so we should see our voltage being greater than 0. So your cell potential is always your cathode, so 0.34 minus your anode, negative 0.76. So we'll plug that into our calculator, 0.34 minus negative 0.76, and you get 1.10 volts. So that is the voltage of our cell. If you found this video helpful, please subscribe.